Like substitution is going to be a bad method of this. Yeah, these problems are difficult enough to keep everything straight when we have integers as our coefficients. All right, if I solve for any of the variables up there, x, y, or z, in any problem, we're going to wind up with fractions. It'll work. You could use substitution on this one, but it's going to be pretty messy. Right. When that's the case, when I don't have x equals, y equals, or z equals on any of these three equations, and it's not necessarily going to be easy to solve for any of those variables and get whole numbers out of them, elimination is going to be the way you want to do it. Any ideas on how we would solve this using elimination? Okay. So we can eliminate which one? Yeah, here's the problem. I see what you're saying. That would make this negative 6y, right? And then if I add all three equations together, I get rid of the y. Problem is, how many variables do I have left? 2, and how many equations do I have? 1. All right, remember we said we always need at least as many equations as we do variables. I like the fact you're talking about the y's. Looking at the coefficients of the y's, I think it's pretty clear the y's is going to be the easiest to eliminate, right? The way we want to do it is we want to combine 2 of the equations and eliminate the y's. So maybe combine the top 2 equations. In this case, I simply need to add them together. So there's 3y and negative 3y. Just like 2 variable systems, sometimes you'll have to multiply one or both of the equations by something before you add the equations together. So adding those 2 equations together, I get 12x. My y's eliminate, which is what I want, plus 6z equals negative 6. Again, I have 2 variables. Again, I only have 1 equation, so I need to come up with a second equation somehow. Where would that come from? Yeah, the last 2 equations. If I combine the last 2 equations and eliminate a variable, it's important that you eliminate the same variable. It does us no good to eliminate the y's the first time and the z's the second time, because I would still have 3 variables. I would still have x and z in the first variable, and then I'd have x and y in the second variable. So I'd have 3 variables. All right, so you want to make sure you eliminate the same variable, which again, I don't need to do anything with on this one because they add together to be 0. 13x plus 9z equals negative 4. Now I'm down to 2 equations and 2 unknowns. So we should hopefully know how to solve that. Okay. I'd multiply this one by 3. And this one by negative 2. Once I get x, where do I go? Yeah. All right, really what we're doing, once we get 2 equations and 2 unknowns, this is my new problem. Solve for x and z in that problem. So I got x. Come back to one of those 2 equations and plug in 1. Got x, I've got z. And now how do I get y? Yeah, one of the original equations. So maybe the very first one. 8 plus 3y equals 2. Make sure as you go, you're circling your answers or write them as an ordered circle. 1, 2, -3. Questions how to solve using elimination. All right, let's try another. Example 2. We've got 2a plus 5b plus 6b equals -2. 3a plus 2b minus 3c equals -18. And 4a minus 2b plus 9c equals -29. Again, substitution's not going to be real good here. We'll wind up with fractions all the way through it. 3 variable systems are not easy to solve by graphing. Well, I guess you have a 3-dimensional graphing that way. Pretty clearly on this one, elimination is the way to go. Which variable is going to be the easiest to eliminate? That's step 1 is deciding which one you should eliminate. None of them are terrible. I think the C's are going to be easy. Yeah, 3, 6, and 9, all of them are multiples of 3. That's going to be probably the easiest. There's not a bad place in the bunch, though. So combine the top 2 equations and eliminate the C's. So in order to do that, I need to multiply the middle equation by negative positive. So I've got 2a plus 5b plus 6b equals -2. I'm multiplying this equation through by 2. Everything through by 2. And now I can add them together. Combine the bottom 2 equations and eliminate this same variable. When I do that, I don't need to multiply through by that 2 anymore. I can go back to the very original equation. So I would want to do what? Multiply by 3. I've got 9c. I need -9c. So I multiply through by 3 there. And put those 2 together. I believe my 2 equations are 8a plus 9b equals -38, and 13a plus 4b equals -81. Any questions getting there? Yep, that's what it says. One thing that you may be able to do sometimes, notice on the last 2 problems, we combine the top 2 equations, and then we combine the bottom 2 equations to get our 2 equations with 2 unknowns. Sometimes it might be easier if I combine the top 2. You don't necessarily have to combine the bottom 2 next. What would my other option be? So I did the first and the second. You could do the second and the third, or you could also do the first and the third, also an option. Of those 3, you need to do 2 of them. What you don't want to do is do the first two and then do the first two again. That won't work. That'll give you many solutions because you're just putting the same two equations together. All right. So the first and the second and the third, or the first and the third, you need to do two of those. The first and the second and the third are right next to each other. Typically, that's how I do it. And you have to do two equations, two unknowns. Hopefully, we know how to solve it from there, right? I think maybe getting rid of the b might be easier. And then multiply this equation by 9, and this one by -4. Add those two equations together. Once we've got A, we can get B. Once we have A and B, we can go back to the original equation. Should be able to get C. Maybe over here. When we get that whole number, the integer of -7, it should be feeling pretty good. All the way back to the original equation gives us the I get -7 to 1. 2x plus 8y plus 5z is -29. 3x plus 3y plus 6z is 48. And 7x plus 4y